Hey everybody, welcome back. We are to the last two sections in chapter 3. We're going to cover both in this one video. And we're going to start with percentile. We're going to start with the definition first of something else called a z-score. And this is the great equalizer. This is if I run a marathon and I look at my time, and someone else took a math test and got a score on it, how could I possibly compare those two numbers? The z-score. This is a great way that we can really do some good comparisons. In general, our z-score is going to be a piece of data minus the mean divided by the standard deviation, be it the sample or be it the population. It's going to be the same. And when we look, if we go 2 standard deviations away from the mean, those are usual, what we called in the previous video. So these are just usual. And these are unusual. If we're more than 2 standard deviations, unusual, and this is unusual. So more than 2 standard deviations or less than -2 standard deviations. And we'll do an example here. Steve Jobs, who was the CEO of Apple, earned an annual salary, excuse me, of $1, which seems unusually low. The CEOs of 50 largest U.S. companies had a mean salary of $1,449,779 and a standard deviation of $527,651. We're going to convert Steve Jobs' salary to a z-score and then decide if it's unusual or not. So z is going to be his salary, which is 1, minus the mean, $1,449,779. I'm going to divide that by the standard deviation. And let's see what we get. 1 minus 1,449,779 divided by the standard deviation, 527,651. And you'll notice we're getting a negative z-score, which is totally fine. That just means that his salary is below the mean, which it clearly is. Negative 2.7476 is what I'm getting. And then they ask, is it unusual? And so this is $1 salary. Oops, $1 salary is unusually low relative to this situation here. Some properties of z-scores. Z-scores are expressed as numbers with no units of measurement, meaning if the data is in inches, the z-score still has no unit. If an individual data value is less than the mean, then the z-score will be negative, like we just saw. We just saw Steve Jobs' salary is a negative z-score. All right, DeAndre is in his first semester at a university and is taking a calculus course with a large enrollment. He just took the first midterm exam and is nervous about his score. Among all the students in the course, the mean of the exam was 55 and standard deviation was 7. DeAndre scored a 74 in the exam. Let's find his z-score and decide if it is unusual or not. So z is going to be, his score was a 74 minus the mean, which was 55, divided by the standard deviation, which is 7. See what we get. 74 minus 55 divided by 7. So we're getting that his z-score is 2.7, and they say round it to 2 decimal places, 2.71. So his z-score actually is unusually high. Right? Because it's more than 2 standard deviations away. It's 2.7 standard deviations away. All right. Goran is in his first semester at a certain university and is taking a calculus course with large enrollment. He just took the first midterm exam and is nervous about his score, which was a 63. among all the students in the course, the mean exam was 83 and a standard deviation of 9. So let's start out by finding his z-score. He got a 63, and the mean is 83. Not looking so good for Goran. All right, so 63 minus 83 divided by 9. Oof, negative 2.22. Yeah. All right. So fill in the blanks to interpret the z-score of Goran's exam score. Make sure you express your answer in terms of positive standard deviations. Now, what they mean by that is Goran's exam score was 2.22 positive, standard deviations below the mean. So it's just in the way that they're wording this. So a negative 2.22 z-score means that it was a positive 2.22 standard deviations below the mean. So his score actually was unusually low in this case. All right. Let's define percentile. Our measures of location denoted in our notation is p sub 1, p sub 2, p sub 3, up to p sub 99. That's going to be our largest one, which divide a set of data into 100 groups of about 1% of the values in each group. For example, the 25th percentile, denoted p sub 25, has at least 25% of the data values below it and about 75 data values above it. We have some notation here. I'm not going to bother with that so much as we don't use it as much. And so I want to go to this example. Here are the test scores for 15 students in Mr. P's class. What percentage of these test scores are less than 78? So I'm going to load this data into my list 1, and you can see my list 1 there, 86, 76, and so on. You may need to pause the video to load this in. I'm going to quit out of that, second quit, which is above the mode button. And what I'm going to do is I need to sort this data in order, and then I'm going to rewrite it in order. That's going to be the easiest way to find our percentile. So I'm going to go to stat, sort A, which is ascending order. And my data is in list 1, so I'm going to hit second and then the 1 button, which has the L1 above it. And now I'm going to go back to my data, stat, edit. And I'm going to rewrite my list here. 34, 47, 51, 58, 65, 67, 71, 76, 77, 82, 83, 84, 86, 87, 88. Now I have a total of 15 pieces of data, and they say what percentage of these scores are less than 78. Well, that is going to be right here. Less than 78. Let's count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9 of them are. So how do we find a percentile or percentage? That's going to be 9 divided by the 15, and then we're going to have to multiply that times 100. 9 divided by 15. Clear. All right, so 9 divided by 15 times 100. So this is going to be the 60th percentile, meaning P sub 60 is the 78, meaning 60% of the data is below a score of 78. Let's also talk about what our data means. Government agencies keep data about the income distribution of the population. The Rivera family and the Choi family live in a county with 5,000 families. The Rivera family's income is at the 33rd percentile. The Choi family's income is at the 26th percentile. So let's make some sense of this. Which of the following must be true about the Rivera families and the Choi family's incomes? The Rivera family earns more than $7,000 more than Choi. No, that's not what that means. The Choi family earns $7,000. No, these are not money amounts here. Both the Rivera family and the Choi family earn more than the median. Nope. The median would mean that they were at least at the 50th percentile or above, and they are not. Both the Rivera family and the Choi family earn less than the median income. That is true. They're both below the 50th percentile. So they're both earning less than the median income. Which of the following must be true about the Rivera family's income? The Rivera family earns about 33% of the highest income in the county. No. The Rivera family's income is at the top half of incomes in their county. No. That would again be 50%, 50th percentile or higher for that. The Rivera family earns $33,000. This says nothing about money up there as far as actual dollar amounts. The Rivera family earns less than about 67% of the families in their county. That's true. That's what the 33rd percentile means, is that 33% about earn less than you do, and 67% earn more than they do. All right. We are moving on to quartiles. Yay. This is why I made it all one video. Percentiles is quite short. Quartiles divide data sets into fourths, or 4 equal parts. So what we're going to end up with our data is we're going to have a minimum piece of data. We're going to have a maximum piece of data. And right in the middle is our median. And then we have our quartiles. Quartile 1, quartile 3. Sometimes the median is referred to as Q3, 2, pardon me. And each of these is going to contain about 25%. Which means that Q1 can actually be written as P sub 25. The median can be P sub 50, Q3, P sub 75. All right, so if we run one of our stats, we're going to get a 5-number summary. And this 5-number summary is going to be the minimum, Q1, median, Q3, and the maximum. The interquartile range, the IQR, is the middle 50% of the data. That means Q3 minus Q1. The lower fence is Q1 minus 1.5 the IQR, and the upper fence is Q sub 3 plus 1.5 times the IQR. And then we have an outlier check, which means, do we have any data points that are less than Q1 minus 1.5 IQR or bigger than Q sub 3 plus 1.5 times the IQR? Let's do this with an example, and we'll look for outliers in the whole deal. Here are the scores of 11 students on a science test. Notice that the scores are ordered from least to greatest. Give the median, lower quartile, and the upper quartile. So I'm going to actually put this data into my list. And you can see, oh, it's in list 2. So 57, 58, 60, 70, and so on. Now it's already in order, so I don't need to worry about that. But what I'm going to run on my list 2, second quit, is I'm going to run 1var stats. And if you remember how to get to 1var stats, 1var stats is going to be stat calc and then 1var stats. So stat calculate up top, 1var stats. And my data is in list 2. So second L2. And you can see they give me my 5-number summary. So the minimum is 57, Q sub 1, 60, the median, 76, third quartile, 79, and the max is at 91. All right. So for this one, they only want the median, which is 76, the lower quartile, which is 60, and the upper quartile, which is 79. All right. All right, this one, we are going to check for outliers and the whole deal. So this list is in my list 3, 27, 36, 36, and so on. So I'm going to run stat, calculate one var stats now on list 3. And my minimum is the 27. Lower quartile is 36. The median is 40. Upper quartile is 46. The maximum is 56. All right, now the IQR, the interquartile range, is the upper quartile, that's 46, minus the lower quartile, which is 36, which is just 10 in this case. So down here, we get our 10, interquartile range. All right, for this next example, we're going to actually find our outliers. So this data I put, I believe, in list 4, 592, and so on. So I'm going to run one var stats on list 4. And Q1, I'm going to actually write the whole thing out. So min, Q1, median, Q3, max. And that's going to be the 592, 596, 599, 602, 607. All right, so Q1 is 596, Q3 is 602. The IQR is 602 minus 596, which is 6. So lower boundary, I called lower fence on mine. It means the same thing, so the lower boundary we'll call it is going to be Q sub 1 minus 1.5 times the IQR. So Q sub 1 is 596 minus 1.5, 6. So 596 minus 1.5 times 6. I'm getting 587. And the upper boundary is Q sub 3 plus 1.5, the IQR. That is going to be 602, 1.5 times 6. 602 plus 1.5 times 6. I'm getting 611. So this is 587, 611. And I'm looking at the data. Is there any piece of data that is below 587? The answer is no. The lowest that we have is 592. Do we have any data that is above 611? No. The largest data that we have is the 607. So in this case, there are no outliers. All right. Constructing box and whisker diagrams. Now, when we're looking at this, the way we're going to interpret this is going to represent our 5-number summary. Down here is 85. This is at 92. This is at 101. This is at 110. And this is at 117. What is the largest number of people served? That is 117. What is the median number of people served? That is the 101 right there in the middle. And what is the first quartile? Right there at 92. So welcome to a box and whisker. I hope you can see the boxes and the whiskers. This is also called box plot. And this is sort of a repeat. I'm going to take this data here, and I'm going to put this into my list. You can see it's in my list 5, 65, 73, and so on. I'm going to run a 5-number one of our stats. And this is in my list 5, which is above 5. And I'm going to list out my data. So minimum, Q1, median, Q3, max. So here I had 51, 60, 68, 76, and 85. All right. So let's look for the IQR, lower boundary, and the upper boundary. IQR is going to be 76 minus 60, which is 16. Lower boundary is going to be 60, that's Q1, minus 1.5 times 16. So 76 minus 60 is my IQR, there it is 16. So 60 minus 1.5 times 16. So I'm getting 36 as my lower boundary. And my upper boundary is going to be 76 plus 1.5 times 16. 76 plus 1.5 times 16. Even 100. And in this case, I don't have any values that are less than 36 or any values above 100. So in this case, no outliers. I'm now going to graph this. Normally what you would do is you would take the graph that you see and you would drag the minimum and the median and all that to the right values. But I don't have that option here. So we're just gonna have to get a little makeshift here. So I'll call this 50, 60, 70. Let's make them further apart. 60, 70, 80, 90. So here's how we do a box plot. The first one is going to be 51. I'm going to put a dot there. Next one is going to be at 60. Then at 68. 76. And 85. And here is our box plot. So you would, with Alex, you would drag, so that bottom one, you drag it down to 51, and then the next one, you drag it to 60, and so on. No outliers in this case. And we are to the last example, where there just might be an outlier finally. I took this data, I put it into my list 6. You can see the 52 and the 68 and so on. So feel free to pause the video to put that in if you need to. And I'm going to run one of our stats again on list 6, which is above 6. So, oops, let's go back to black here. Minimum, Q1, median, Q3, and the max. So we have 37, 58.5, median is 66.5, 69.5, the max is 88. And let's find the IQR. It's going to be 69.5 minus 58.5. 9.5 minus 58.5 is 11. Lower boundary is 58.5 minus 1.5 times 11. And the upper boundary, 69.5 plus 1.5 times 11. 58.5 minus 1.5 times 11. And that is giving me 42. Boundary is 69.5 plus 1.5 times 11. It's giving me 86. Which means we have a problem, because I can see that 37 is an outlier. Let me pull up the data again. So again, we're looking at list 6 here. And I'm going to sort list 6 so we can see it in order. So we can see 37 is too small. That's below the 42. So actually what I'm going to do is I'm going to cross that out. That's no longer my minimum. My minimum is now 43. You can see below the 37 in list 6 there. 43 is above 42, so we're good. Let's go to the bottom of the list. I see that 88 is too big, so it's out. We have an outlier. And the next data piece is going to be 85 for our maximum. So let's talk about what that looks like. Again, I can't drag and drop like I would like to. So I'm just going to make my own. And as I'm looking at the data, I'm going to go 30 through 90. So 30, 40, 50, 60, 70, 80, 90. And I'm going to go to my outliers first. I'm going to go to 37. I'm going to put an asterisk. And I'm going to go to 88. And I'm also going to put an asterisk. All right. Now I'm going to put in the new data. So we have 43, 58 and a half, 66 and a half, 69 and a half, and then we go out to 85. And here is my box plot. Yeah, you could probably draw it much nicer than I could. I hope that was helpful. Thank you very much.